Hello friends, thank you for watching this video. I am Mohamad, and last week Microsoft released .NET 7. .NET 7 brought with it a lot of new enhancements, bug fixes, new features, as well as a lot of performance gains. So in order for us to celebrate this, I have created a .NET 7 course, specifically in web APIs, taking you through the entire process of creating different CRUD operations, connecting to a database, implementing unit of work, so on and so forth. So if you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Now, grab your cup of coffee and let's get started. We're gonna start first by exploring what is new in .NET 7. We're gonna be seeing basically the new features. Then we're gonna be seeing how we can actually install .NET 7 on our machine. Once we install .NET 7 on our machine, we're gonna be seeing how we can create our application and basically start implementing our full CRUD operation with Entity Framework 7. So, what I did here is basically I went to the release block of .NET 7 where we can actually see that there is a lot of new functionality that has been added. So here we can see within this block form, they can tell us basically what is new within .NET 7. And one of the main two things that we really want to focus on is basically the ASP.NET Core 7 release as well as the Entity Framework Core 7. And on top of that, there is multiple other upgrades to .NET MAUI, to Windows Form, to .NET Orleans, so on and so forth, as well as the new C# features. But for the sake of this video, we're going to be focusing basically on ASP.NET Core 7 and Entity Framework Core 7. And any other feedback or basically any other new features that you want to explore, please put it in the comments down below and maybe I can create a video about it later on. So let's go to the ASP.NET Core 7. And here we can see basically some of the main new implementation or some of the main new enhancements like rate limiting, request decompression, HTTP3, minimal APIs enhancements, gRPC, SignalR, MVC, so on and so forth. So we're not going to be really implementing a lot of these new features. We're going to be basically, for the first step, we're going to be implementing like a basic CRUD operation where we're going to be updating all of the main CRUD actions, and then we're going to be able to connect it to our database through Entity Framework Core 7. And this is going to be like a stepping stone. Then we're going to be implementing, based on that, within the next video maybe, we're going to be basically adding more functionality into that. We're going to be maybe implementing rate limiting. We're going to be adding some more functionality based on the new functionality that has been implemented within .NET 7. So now let's take a look at as well what is new in Entity Framework Core 7. And within this Entity Framework Core 7, we can see that some of the main implementation, some of the main feature is table per concrete type, TPC mapping, so on and so forth. There's a lot of new exciting functionalities that's coming within AF Core 7, which can basically allow us to have a much more better rigid and structured DB experience. So I think rigid is the wrong word, but a more structured, I think that's better. So, and there's a lot of bug fixes when it comes to AF Core 7, which is really, really important. So once we have done all of that, and basically once you have read all of the new releases when it comes to Entity Framework 7, basically the next step for us is we need to actually upgrade to .NET 7. So how can you do that? All you need to do is go to download.net, and basically once you go there, you will be able to see that you're gonna have two types of download. So .NET right now comes in two flavors. There's gonna be the current version and the LTS version. So the LTS version is gonna be a long-term support, which means that this .NET version is gonna get all of the security updates and all of the patches for the next 2-3 years, actually 3 years. And because it's a much more stable support, so if you're trying to build like an enterprise application, it's much better always to have an LTS version rather than have a current version, because you know all of the security updates is gonna come to that version until the end of life. On the other hand, the current version, it basically have all of the latest and greatest functionality that the .NET has to offer. It has all of the latest changes that every year is going to be released. It has all of the latest security patches. But the main downside within that is basically once it reached its end of life, which is usually 1 year, you have to upgrade to the next version because it will not get all of the latest security updates. So here you need to see what is the best implementation for you and for your application and for your organization. Do you want to be on the latest version? Then you need to go with the current one. Do you want to be on the most stable one with get the latest security updates? That's going to be the LTS. For the sake of this video, we're going to be downloading the latest one, which is going to be the .NET 7. So, and here we can see that it says standard support, term support, and we can see here that it has a long-term support. And we can see as well that both of them are available for us to download, and all of them support different types of operating system, like they support Windows, Mac, Linux, and even support ARM, so it's going to be the M1 chips. So here also we can see some of the new additions to .NET 7. We're not going to go into this right now. So once we decide, you can click on download, and we can see that you can download the .NET SDK 64 on ARM. So that's what we want. What I'm going to be doing as well, another way we can actually upgrade is basically upgrade our homebrew. So right now, if I go to my terminal and I type .NET -- version, I can see that I have the latest, which is 6.0.402. But if I type brew upgrade, now this should upgrade my .NET version to .NET 7. And this should take a few moments to complete.
A few moments later.
Okay. So now that the upgrade has been completed, and basically now if I do .NET -- version, I should be able to see that I'm running on .NET 7. So let's see again, .NET -- version, and here you can see I'm running on the latest version, which is going to be version 7.0.100. Perfect. So now what I'm going to be doing is I'm going to be going through Rider, and I'm going to be creating, actually what we can do is I can create a new web API through the command line, and then actually utilize Rider to open and edit it. So for .NET 7 you can use, for example, Visual Studio, which has been released with the latest support for .NET 7. It has contained all of the new features. You can utilize Visual Studio Code as well. You can utilize Rider. There's a lot of different tools out there that you can actually utilize to create your .NET application. For the sake of this video, I'm going to be utilizing Rider, but please feel free to utilize anything. And you are on Windows, you can use Visual Studio on Windows, which is 2022.4, which has the full support of all of the new features that .NET 7 has to provide. So now let's go to desktop, work, learning, .NET. I'm gonna create a new folder. I'm gonna call it .NET 7. And then from here, I'm gonna just create a new .NET, new web API. And I'm gonna call this one let's say, formula API. And that's it. That's all we want to do. Perfect. Now I'm going to open Rider, and here I'm going to click on open, work, learning, .NET, .NET 7, formula API, and then open my formula API. Yes, I do trust. Perfect. Now my application is building. We can see here it does not have full support yet, but that should be fine. And now if I open this, let us first, so now that our application has been created in .NET 7, first we're going to be exploring the solution a bit. We're going to be seeing the different changes. Basically there's not going to be a lot. It's all going to be a change into CSproj and the packages, and from there we're going to actually start by creating our models, so on and so forth. So let's check our CSproj, and then here what we're going to be doing is edited, and we can see here that the main items that had changed, which is going to be the target framework, and the target framework here is going to be .NET 7. On the other hand, if we look at any other application, let me open another application. Let's see the Formula Airline, for example, new window. So this one, this was an old application for an old video, but if we take a look at the old CSproj, okay, where is it? We can see that the main differences here is this. let's put them side by side so it will be easier for us to see. Let's close this. We can see here that in the new one we are targeting .NET 7 target framework, and in the old one we're targeting .NET 6, and that's all it is. All we need to update if you're upgrading from .NET 6 to .NET 7 is just update the target framework, update the packages, and then you should be ready to go. And as simple as that, the upgrade is done. There's not going to be a lot of major changes like moving from .NET 5 to .NET 6 where you basically the entire startup class has been removed. There's none of that in .NET 7. When you're upgrading from .NET 6 to .NET 7, make sure you are targeting the right framework and then updating those packages. So now this is be fine, we don't really need this anymore. And the first thing that I'm gonna be doing is inside my terminal, I'm just gonna type .NET build to make sure that my application is building successfully. Exactly, perfect, that's exactly what we want. And now let's start by cleaning up this a bit. So first of all, I don't really need this anymore, the weather controller, so let's delete this. And it's gonna create issues here in my controller, which is fine, I don't need this. Just doing some tidy up. And here, I'm just gonna be returning a iAction result. And here we're just gonna be returning let's just return, okay, we don't need this. And that should be it. So if I do .NET build, okay, great. So the first thing that I'm gonna be doing is I'm gonna create a new folder, a new directory, and I'm gonna call this models. And inside my model folder, I'm gonna create my first class, or actually first model, I'm gonna call it drivers. So what type of properties my driver is gonna have? It's gonna be very simple. First, let's put we're gonna give it a string as name, or let's put an ID prop int ID. Let's give a driver's number and then int, and let's put also the team that they race for. Team. Very simple. Okay, so now that we have our drivers models, basically what we have here is we have created a very simple model which can be representing an entity inside our database, and this model is called driver and it has 4 properties: ID, name, driver number, and team. It's a very simple implementation. So once we have done all of that, the next step is we're gonna be going to our controllers, and I'm gonna create a new controller. I'm gonna call it drivers controller. And basically here we can see that the controller has been created. First of all, I don't want to utilize the entire controller, so I'm just going to utilize controller base, which is a simple version of that. I don't need this, I'll add it later. So first things first, what I'm going to be doing is right now I'm going to be creating an in-memory database. So different actions that we have, the get, post, patch, and delete. We're going to add those, we're going to be experimenting with them. And within this in-memory database, once we make sure that they are running, what we're going to be doing is we're going to actually create DB context. And once we create our DB context, we're going to be updating our controller to utilize this. As well, once we have done all of that, we're going to be actually experimenting with it. So maybe we're going to add more services to it. So let's see how this will go. So first things first is let's create this first our in-memory database. So it's going to be a public, let's make it private actually. Let's make it private, read only, and it's going to be a list of driver, and I'm going to put drivers equal a new driver list of drivers. And just to make this a bit simple and much more easier to do, I'm going to be creating default drivers. So as soon as this application is created, we're going to have few drivers there. So the first driver is going to be, of course, Lewis Hamilton, Sir Lewis. Team is Mercedes AMG F1. and driver number, it's 44. And then we're gonna add another driver, new driver, ID equal to name equal George Russell, same team, and congrats George on winning your first Grand Prix, Mercedes AMG F1, and driver number is 63. Let's add another driver. It's gonna be new driver, and which this driver is gonna be, let's see. Okay, let's put ID equal 3, name Sebastian Vettel, Sebastian, driver number, I think it's 5, and the team, it's the Aston Martin. Well, now that we have created this, the first one we're gonna be doing is the HTTP GET, and basically here we're gonna put public action result. I'm gonna put GET, it's not gonna take anything, and all we're gonna be doing is return OK, and we're gonna return the drivers list. As simple as that. So this is a very simple API. Directly we just got the database from in-memory, and we're gonna be trying it out. .NET build, and then all I'm gonna be doing is I'm gonna say .NET run, and let's open this. And we're gonna put /swagger /index.html. Perfect. Okay, so we only have one of them. Why we don't have the second one? Okay, when we created this, we did not add all of those different specifications to make sure it's an API controller. So let's add these. Now let's just stop this and run it again. And now we should be able to see it. So let's refresh. Perfect. And now if I do try it out, execute, I should be able to see my 3 drivers available for me. Perfect. So now that we have created our first action, which is going to be the get, the next one is going to be get by ID, where we're going to be passing an ID and we'll be able to get the results that we want. And then after that, we're going to be adding them. So it's going to be a post, and the one after that, we're going to be deleting them. So let's take this into, and let's see how this is going to work. Let's make sure this is in the right frame. Okay, perfect. So now let's go back to Rider. And now we're going to get by ID. So it's going to be, again, HTTP GET, public, action result. Okay, let's stop this. Don't need it running. We're going to put get by ID. Actually, we can just make it like this. And we're going to be returning, okay, drivers dot first or default, and we're gonna be finding it based on the ID. Perfect. Let's now run this again. Now we have drivers got by ID. So now let's try it out. I'm gonna put ID 1, and here I should see Sir Lewis. And if I go down, I'll be able to see that I got Sir Lewis. And if I put ID 2, I should get George. ID 3, I should get Sebastian. Okay, so now that I have the second endpoint working, so first is get all, the second one is gonna be get by ID. The third one, I'm gonna be able to add drivers now. So it's gonna be a post. So now let's do this right now. So inside, let's stop this. Let's put this down. And here what I'm gonna be doing, let's make sure this is in the right frame. Okay, that's fine. So here, oops. Now we need to add the new actions. It's gonna be HTTP post. And we're gonna add the route. I'm just gonna call it add driver. Public action result driver, and it's gonna take a driver. I'm gonna call it driver. Very simple, straight to the point. Return okay underscore drivers dot add, and we're gonna add the driver. Very simple. Why is not happy? Let's see. Okay. So because adding does not return anything, so I'm just gonna put this here, and I'm gonna be returning an okay. So now let's run this again. .NET run. Now if let me refresh this, let's try the add driver, try it out. I'm gonna utilize the ID. I'm gonna give it the ID number 4. Let's see who we wanna add. Let's put say let's put Sergio Perez. He should actually have that's a different story. So let's put driver number. I think it was I think it's 11, and it's Red Bull. Okay, now let's try this. Execute. We got a 200, and now if I do get all drivers, try it out, execute, I'm basically not able to see it here. Why? Oh, I think I know why. Because I made it read only. Let's make it static. So let's stop this, and let's run this again. And now let's go back to my web browser, and let's add this. And now let's execute this. And here I can see that I have Sergio has been added into my database. Okay, perfect. So now that we have created the main 3, which is gonna be the get all, get by ID, and post, we're gonna see the delete and then patch. And then once we have covered all of that, we can actually now move into the next step, which is actually creating our DB context. So let's go back here, and let's stop this. Let's put this down. And basically here, what I'm gonna be doing is I'm gonna put HTTP delete, because we're gonna be deleting. And I'm gonna put route delete driver, and I'm gonna put public action result delete the driver, and all I'm gonna take is the ID of the driver, and it's gonna be very simple. So first of all, we need to find the drivers, so we can put var driver. Actually, let's make it driver equal drivers dot first or default, and we're just gonna match it on the ID. Equal ID. So if all of that is working as it should, what I need to do is I need to put underscore drivers. Okay, so let's make a double check. So if driver is not equal to null, so actually if it is null, we're just gonna return not found, and then we stop the request here and there. Return not found. Else, if it actually there is a driver, all we need to do is drivers dot remove, and I'm gonna pass the driver here, and then all I'm gonna be returning is no content, and that's it. So let's try this out. So first we need to run it, so let's go to terminal, .NET run, it's running. Let's go to our web browser, and let's add Sergio again, execute, and then let's run this again. We should be able to see 4. We have 4 of them. Now let's refresh this. We can see that we have our delete drivers. Let's do this again to make sure that it's there. Try it out, execute. I can see the 4 drivers. Now I'm going to be removing Sergio. So try it out, ID number 4, execute. We got a no content, which is exactly what we want. And now if I go here and select all drivers, I'm able to see only 3 drivers. Perfect. So that means that our delete is working as it should be. So once that has been completed, I think we have completed now 4 out of our actions. The last one is going to be patch, and basically patch is going to allow us to update our records inside our REST API. So let's go back to our riders. Let's stop this. Let's make this smaller. And here what we're going to be doing is we're just going to put HTTP patch. And we're going to give it a route. Update driver. Public. iAction result. Update driver. And it's going to take a driver. And we're going to be doing the same thing as we have done previously. We need to make sure that this driver exists. So var driver equal underscore drivers dot first or default, matching it also on the ID. Okay, let's change this name from exist driver. Yeah, it needs to be capital. Driver.id. Okay, so similar if driver, actually exists driver, is equal to null, we're going to be returning not found. Else we're going to be updating it. So we're going to be, let's say, driver, actually existing driver dot name equal driver dot name existing driver dot team equal driver dot team and existing driver dot driver number equal driver dot driver number. Okay, and then all we're gonna be returning is no content. Okay, so now let's run this. Perfect. Now let's go to our web. Let's refresh this. And here we can see that we have our patch. Let me get all, execute. We got everything here. So let's see this. And let's update Sebastian. So if we're gonna change, for example, Sebastian's team, we're gonna be changing it from Aston Martin, for example, to, let's say, which team? Let's say to McLaren. And let's execute this. And we got a 204. And now if I execute this, I should be able to see that Sebastian is now moved from Aston Martin to McLaren. Perfect. So now that we have covered the five actions that we needed, which is get by ID, post, delete, and patch, the next step for us is we're going to be actually connecting to a database, which is going to be a SQlite. And once we connect to a database, we're going to be creating our DB context. We're going to be actually adding migrations, seeing those databases actually seeing the database, seeing the table inside the database. And once we do all of that, we're gonna be basically winding it up into our controller, and then we're gonna be basically updating all of the actions so that we can take benefit of that. So in order for us to do this, the first step is we need to install some packages. Okay, so now let's go back to Rider, and I'm gonna stop this, and let's start installing our applications. So, install our packages. So the first thing that we need to install is .NET add package Microsoft.entity framework core.SQlite. Perfect. The next one is going to be .NET add package Microsoft.entity framework core.tools. Perfect. So now that has been done, let's do .NET build again. And now if we go to our CS project again, so just so we can make sure that we're utilizing .NET 7 packages, we can see here that all of our packages are basically referencing the latest and greatest, which is going to be .NET 7 version 7.7.7, exactly, except Swashbuckle, which is still on a bit of an older version. But other than that, all of the Microsoft NuGet packages are following the .NET 7 versions, which is great. So once we have done all of that, the next step for us is to start actually creating our DB context. So inside our application, we're going to be creating a new directory, and we're going to be calling it data. And inside the data, we're going to be creating a new class, and we're going to call it API DB context. And here it's going to be very simple. So the first thing that we want to do is we want to inherit from the DB context class. And then once we have done all of that, the next step is we need to actually create a constructor. So it's going to be ctor, and here I need to pass the configuration. So I'm going to put db context options, and I'm going to pass API db context, and then here I'm going to make it as options, and then I'm going to pass this to the base class options. As simple as that. And now once I have done all of that, now I need to create my table, and the way I do it is going to be public dbset. It's going to be called driver. So because we want a table called driver, I'm going to call this drivers. We're just going to make it get and set. So let's put this here. Perfect. And now if I do .NET build, everything should be building correctly. Build succeeded, great. So the next step is I want to actually create my connection string. So here I'm just going to add connection strings, and I'm just going to call this default connection. And it's going to be a very simple one. So we're going to put the data source equal, just going to call it f1.db, and we're going to put as the cache equal shared. Okay, that should be fine. So now that we have added our API DB context, we added the connection string, the next step for us is we actually need to update our program.cs so we can inject our DB context into the DI container of our application. And once it is there, we can actually utilize this. So let us go to our program.cs, and inside our program.cs, what we're going to be doing here is let's inject this. So in order for us to inject it is before we actually do the app builder, we're going to do it here, let's say on line number 10, and we're going to put builder.services.add db context, and we're going to be passing the API db context that we had, exactly. And then once we have done all of that, we need to pass the options. And let's put this in a new line. Oops. And put options dot use SQlite. And then from here, all we need to do is just make it utilize the connection string that we have. So it's gonna put builder dot configuration dot get connection string, and we're just gonna pass the connection string name, which was, I think, default connection. Let's copy this and program.cs, and let's put this here, save. And now once we have done all of that, let's do another .NET build. Perfect. Now our application is building successfully. So right now what we have is we have created our API DB context with our table. We have wired it up into our application. We added the connection string. The next step for us is we need to create a migration script, because currently what we have here is we have a database implementation of our application, but we don't have a database. And the way we're going to be utilizing that is we're going to be utilizing the EF tool. That's going to allow us to actually translate our requirements from our application DB context into the actual database itself. So first of all, we're going to be seeing how we can actually install the CF tool. It's very simple. And then once we install it, we're going to be seeing how we can utilize the migration in order for us to create the skeleton of our, basically the DDL files of our application. And then we're going to be seeing how we can actually create create the DDL for our database, and then we can see how we can actually create our database utilizing the migration tool, or basically the entity framework tool. So let's go to our web browser and let's look for EF entity, let's say entity framework. Tool, let's put terminal, and let's see how we can install it. So let's see if this is clear. Yep. So we can see here, in order for us to install the tool, all we need to do is just put this inside our terminal. So because I'm on Mac, I can put it inside my terminal. If you are in Linux, what you can do is, if you are on Windows or Windows, you can put inside your PowerShell, inside your Windows terminal, and it will be able to work as well. So let's open my terminal. And because I have already installed an older version, let's see what's going to happen if you already have an older version. It's going to tell you that's already installed, you need to update, but let's do it. .NET tool install --global .NET-EF, and we can say it's already installed for me because I have already a previous version, but for you, if you don't have a previous version, it will install there. Now if you already have a previous version and you want to update, it's very simple. We're going to put .NET tool update --global .NET-EF, and now it's going to update my tool, and we can see here that my tool has been updated successfully from the latest version, which was 6.9, which was supporting for .NET 6, to the version 7, which is the latest version that we are currently on. And that's exactly the one that what we have needed here is to actually utilize all of this in order for us to basically utilize the power of the entity framework, utilize the power of Entity Framework Core 7 in order for us to be actually utilized inside our application. So it says here as well that we need to add this package.microsoft.design into our application. So let's add this package. So let's copy this. Let's go to Rider and let's add it. And now that we have installed all of that, now if we go back to our CS Proj, we can see it has been installed successfully, the design. And now let's start with creating a migration. So the entire concept behind creating a migration is as follows. So we have our class, we have our application DB context, but we don't have the actual SQL file that's going to be responsible for creating our application. And because we don't have the actual SQL file, we're going to be relying on Entity Framework in order for it to actually create the translation with whatever we have inside our C# classes into an actual SQL file. And that's what the migration means. It means migrating from SQL, from C# to SQL. And that's going to be fully done by entity framework core. We don't have to write it manually. Everything's gonna be managed for us. So let's do this right now. So we're gonna put .NET, and because it's a .NET, it's a part of our .NET framework, we're gonna put EF because we're gonna be referencing the entity framework tool, and then we're gonna put we're gonna put migrations because we're gonna be adding a new migrations, and we're gonna make sure that we're gonna be adding it. So .NET referring to the .NET framework, EF referring to we're gonna be utilizing the entity framework tool. Then we're giving it the command. We're gonna give it what do we want to do with entity framework. So we're gonna say that we're gonna be utilizing the migrations, and then we're giving it what is the action within the migration add, and then we need to give it a name, and I'm gonna put initial migration. So now this should run, and I should be able to see a new folder popping up here, which is called migrations. Sometimes, it's appeared. And here we can see that I have a new migration file has been created, and we can see here that I have a representation of my database within SQL. We say the ID is an integer. It's basically the primary key. It has auto increment. I have the name, which is text. I have a driver with driver number with an integer, and the team is a text. And we have seen that it has attached a primary key to my table. Perfect. So now that I have created the migration, the next step is basically I need to actually execute this migration. So it's always in two steps. First, we prepare it. We see the script that has been created to make sure everything is as it should be. And then once we actually see that this is the case that we want, or basically this is what we want, we can actually implement this into our database. And the good thing for us here, we don't have to specify a connection string. We don't really have to specify to which database, because the EF tool will be able to go to our application, check whatever connection string that we have, and it's going to do this migration for us. So let's do this right now. .NET EF database update. And now if you take a look here, before I run this, you can see that I don't have a SQlite database for me. But once I execute this, it says completed. And now if I come here, I should be able to see my f1.db has automatically been created for me. And if I open this, yes, let's connect with this. Let's download the missing drivers. Let's say test connection. Perfect. Now if I open this, got it. And if I open my database here, let's refresh this. If we open the tables, we can see here that I have my drivers table. And if I open my drivers table, I see the columns. I have my ID, name, driver number, and team. So what happened here? So basically, once I ran the database update command, what it did is actually it went through the migration folder. It checked all of the migration that exists there. Then it checked, do I have this database? Yes. If I do have it, it will create it. If not, if it does not have the database, it will create it. If it does have it, it will skip the step. Then it will check what type of migrations that I need to implement into this database. Do I have all of it start comparing the migration. So it checks how many migration exists in the folder, and it checks how many migration exists inside my database. And if they are equal, nothing will happen. If there's, for example, one inside the migration folder that exists and it does not exist inside my database, it will implement that migration file into my database. And it's the opposite. If I remove a migration file from my database, it will actually revert those changes. But be careful, when it reverts, there might be data loss there. So be careful whenever you're trying to revert any migration. So that's basically the essence what happens to Entity Framework when we're doing the Entity Framework core tools. So now what we're going to be doing is we're going to go back to our drivers controller, and inside this drivers controller right now, what we're going to be doing is we're going to be updating it in order for us to actually utilize our DB context. And once we actually implement our DB context here, we're going to be seeing how we can actually save all of this information to our database rather to our in-memory database. So first things first, let's go up here And what I'm gonna be doing here is basically I'm gonna be removing all of this because we don't really need this anymore. And basically what I'm gonna be doing is, okay, so let's start adding our DB contacts. We're gonna put private read only API DB context underscore context, and then we need to create our constructor, and I'm gonna pass the API DB context here, so it will utilize dependency injection in order for it to get all of the DB context option that it needs. I'm just gonna make it context, and then once I have done all of that, I'm gonna put context equal context, and then once I have done all of this, now what I can do is just basically refer to my API DB context to go to my database, get all of the information that I need, and once I have done all of that, it's gonna make it really easy for me to basically get any information that I need from the database, save information in my database, and update it. So let's update first our get. So here what we're gonna be doing is, instead of connecting to the drivers, I'm gonna put context the drivers dot to list. It's very simple. Actually, let's make it to list async, and let's make this as an await, and let's convert this into an async method, async, and let's put here task, and let's put this here, and let's save this. So basically here what we're doing is we are basically connecting to our DB context. We're telling it that you need to go to the drivers table. Once you get to the drivers table, get me everything that you have there, put them in a list. So that's what we have done here. So the next step for us is we're gonna be getting by ID. So let's do this in a different line, so just to make it easier for us to see what's the difference. We're gonna put var driver, which is the driver that we wanna get. And basically what I want to do here is I'm gonna put, again, connect to the, let's make it await, because it's gonna be an async request. We're gonna go to context, and then I'm gonna put the drivers, and thus I'm gonna put first or default, again based on the ID. So same condition as I had before. ID, and here let's see. So this is still not happy. Let's make this as an asynchronous action. Okay, so let's see what happened. So first of all, I connected to my DB context, I connected to my drivers table, and then what I did here is I told them to get the first or default async whenever you match the ID to that ID that I'm passing. And we can do this after this. I can say if driver equal null, I'm gonna return not found, and then based on that, once that is done, all I'm gonna be doing here is I'm gonna put driver. I'm gonna return driver with an OK. Perfect. So now this is my second action has been updated. So two is down, 3 more to go. So now I want to update my post. Again, it's very simple. So all I need to do is I want to actually refer to my DB context. So I'm going to put context. Again, what do I want to do is going to be driver. And all I'm instead, if I want to add stuff, I want to add. And I'm going to add the driver as is. And then here what I'm going to be doing is I'm going to remove this. And the way that I also want to do is I want to save those changes into my database. So context.save changes async. And let's make this awaitable. And let's make this as async as well. Perfect. Perfect. So the next step is it's going to be similar to the get drivers. So let me copy paste this instead of me writing it all over again. And let's make this as an async as well. Async task. And here, if I do this, perfect. So now how do I delete from my database? Very simple. The way I do it is I connect to my database contacts, drivers.remove. And here I just pass the driver. And then I need to save those changes. So await underscore context.save changes async. And I can remove this. Perfect. Next, and this is going to be the last one, which is updating the driver. Again, it's going to be the same logic. So let me get this. oops. I'm gonna call this exist driver. And let's make this again as an async task. And here what we have done is basically context again, connect to the drivers. First or default, we need to update this so it will utilize whatever is inside that object. Driver.id. And then once I have done all of that, I'm able to update it. And the way do I just save those changes? We just await underscore context dot save changes async, and that's it. And now basically if I do .NET build, we can see that the build is succeeded. And if I do .NET run, it is running. So let me go to back to my web browser, and let me go to my Swagger file, and let me refresh. And here I can see that I have my 5 actions. It's not because I'm utilizing the database. The database right now has my table, but it's empty. So now if I do get all or get by ID, it will not be able to find anything. But once I start adding, I will be able to utilize these actions. So let's try the drivers first. This should be empty now. Execute. It's empty. Get driver by ID. Should give me not found. We got an error, not found. Perfect. And now let's see trying adding a driver. So ID equal 1. Name is Lewis Hamilton. Driver number is 44. And team Mercedes AMG F1. Execute. We can see I got a 200, and now if I click on execute on get all drivers, I'm actually able to get all of my drivers, basically a driver that I've just added. And now let me go to Rider again, and let me open my database. And if I click here and I can see, do I see view data? Yeah, added data. I'm able to see inside my database that I have Lewis information already added directly there. Perfect. Now let me add another driver. Let's add another driver. So just to make sure that we have multiple drivers. So the second one is going to be George. Russell 63. Same team. And now if I put get all, I'm able to see both of them. And inside here, if I do refresh, I should be able to see the 2 drivers available inside my database. Perfect. Now, if I come here and put get driver by ID, so if before it was 404, now if I click on it, I'm able to see a 200, I'm able to see Lewis. If I put driver ID 22, I'm able to see George's information. Perfect. So now that we have made sure that our get all is working, get by ID is working, and post, let's try the delete driver. So let's say I want to delete George, so put 2. Execute. We got a 204, and now if I come to my database, refresh, it should not be there anymore. And if I come here and put select all, we should be only seeing Lewis. Perfect. And lastly, if I want to update the drivers, so it's going to ask me the driver number is going to be 1, name Lewis Hamilton, driver number is 44, and the team is going to be Mercedes AMG F1 Petronas. And execute. I got a 204, and now if I click on get all drivers, I should be able to see the team updated from Mercedes AMG F1 to Mercedes AMG F1 Petronas. Perfect. And now if I look inside my database and I refresh this, I'm able to see that the team name has been updated to Mercedes AMG F1 Petronas. Perfect. So right now what we have done inside this, so far inside this video, is basically we created an .NET 7 web API. We utilized an in-memory database. We created 5 actions: get all, get by ID, post, patch, and delete, and we were able to see how that works. Then we have added our tables. We have added our DB context, and then we have wired it up inside our application to make sure to work as it should be. And then we have updated our controllers so they will take full advantage of our DB context and make sure they're working as they should. And then once we have done all of that, we have tested it out, make sure that everything is running. And as well, we have installed the entity framework tool. We were able to understand how the migration work, database update works, so on and so forth. So this is the full overview. But now we're going to take this a step further, and we're going to be seeing how we can actually implement unit of work, which is a way where we can actually communicate with the database without actually referring to the DB context directly. So what we're going to be doing here is we're going to be creating a service space approach, which is the unit of work, to our database. And once we actually create the service space to our database, what we're going to be doing is it's going to allow us to actually inject our service inside our controller and then refer to it from there. So basically we put all of the logic that we want to manage our database in a separate place, and all we need to do is just refer to it to what we need and basically call those actions from there. So let's get started. So what is a repository pattern? The repository pattern and unit of work is basically an abstraction where we are able finally to decouple our APIs or basically our web application from our data layer. So we're able to do separation of concern where basically any changes to the data, it will be within the data layer, and basically our application will be able to consume it rather than having those two embedded together. That's why it's a much better approach for us to actually separate them and have them completely separate. So the unit of work and the repository pattern will basically allow us to have these decouplings between our application and our data layer. And one of the main benefits of this is basically, for example, it will allow us to have a much more better approach when it comes to TDD, development test-driven design, because in that way we can actually mock all of our database stuff without actually having to rewrite anything within our logic class and our web APIs. Because all of those can be actually switched over within, for example, a mock database. And that way we can actually have a much more better testability of our application. As well, it will make all of the layers loosely coupled within dependency injection. So we don't really have to be hard coding them inside our application. So for example, if I want to change my database from Postgres to SQlite, I can easily just switch it up within the data layer. The application will not be affected. If I want to switch it to SQL Server, MySQL, to a non-SQL DB, my application will not even know that's changed. The data layer will be taking full charge of that without actually affecting my application layer in any single way. So that here we can see that this decoupling between the data layer and our application, it's a really, really powerful thing. And it's something that really we need to actually implement within our application in order for us to have that flexibility. And basically this flexibility will allow us to have better testability of our code and much more stable application. So first things first is inside our formula API, let's create a new folder. So I'm going to put add directory, and I'm going to call this core. And inside my core directory, I'm going to be creating a new interface. And this interface, I'm going to be giving it a name generic repository. Perfect. Let me close this for now, my database. And what I'm going to be doing here, I'm going to make it generic. And then the reason that I made it generic is because let's say in my database I have 100 tables, 15 tables, 20 tables, no matter what the number is. I don't want to excuse me, I don't want to recreate all of the interfaces specifically for the default patterns for all of them. So what I can do is I can create a generic one, and then basically what I can do is I can implement those inside the tables one. So let's say I have 3 tables, I can just refer to the generic one and basically do the implementation from there. So right now I'm going to be also doing here, I'm going to be adding all of my default actions that we usually do against the database. So it's going to be tasks, enumerable of t, and this is going to be for get all, or let's make it call it all. And then I'm going to put task of t. For example, here is going to get by id. So you can see here that we are referring to all of the default CRUD action that we might want to do against a single entity, and that's why it is a generic one, because whatever the table is or whatever the entity is, we're gonna basically even get by ID, add, update, and delete. So these are gonna be basically whatever the table is inside our database. There is a big chance that we're gonna be utilizing these 5 actions against it. So it's good to make it as a generic repository in order for us to directly utilize it instead of rewriting it every single time. So once we have done that, then we can put task as boolean, and we're just gonna put add, and we're gonna pass t as an object, and then we're gonna put task bool, and this is gonna be update, and we're gonna put t again entity, and lastly we're gonna put task bool delete t dot entity, not dot entity. Perfect. So once we have created all of that, the next step is inside our core, we're going to be creating another interface, and this interface is going to be referring to our driver interface. So I'm going to put driver repository. I'm going to put actually that's not here. So now that I have my driver repository, I can just refer to the generic repository and make sure that this is for a driver. So, and this is not a class, it's an interface. Okay, so what did I do here? So right now, if I create driver table, if I have a teams table, if I have a FIA table, if I have any table that I want inside my application, let's say I want the equipment, the cars, the personnel, all of that. So all of those tables, we're gonna have the same actions: add, update, delete, get information, get by ID, all of that. I don't wanna recreate those things, so that's why we can see here that through the generic one that I have created, I was actually able to refer to that interface, and basically I have passed the type of object to it. So because I have made it as a generic of type T, I was able to refer the driver here into the class. So as you can see here, I was able to make sure that for this generic type, I was passed a driver. So we can see here that it says T is a driver. So the generic object that was T, now it's being deferred to as a driver, and now I'll be able to utilize this repository with all of the actions that exist within the generic repo. So I hope that makes sense. So now basically for anything within the iDriver repository, all of those actions is going to be basically belonging to the driver table. So once I have done all of that, the next step for me here is inside here, I'm going to be getting a new interface again, and I'm going to call this unit of work. Perfect. So here what I'm going to be doing, I'm going to refer to my interface, and I'm going to put driver repository. I'm going to call it drivers get, and I'm going to of course make the task, which is going to be the complete async, which is basically going to refer to save changes. Perfect. So now that I have my unit of work ready, and the reason that I want to have my unit of work ready here is basically what I want to do is I want a way. So the reason, so let's just take this step further. So what is unit of work? The unit of work is a way where we can actually abstract all of the logic of my databases. And the way that I'm doing that right here is for every single table, I'm creating a set of instructions that I want, or actions that I want to be able to execute against this table. And I want basically a way where I can put all of these instruction sets for every single one of them. And the best way to do it, because we're going to be utilizing as well the dependency injection, is to have the interfaces and then have the implementation. And basically what I can do is, because if I'm going to have a lot of interfaces, a lot of implementation, I need a way where I can actually map those two together. And here the unit of work allows me to actually do those mappings. So the way that I do it, first I have created right now the unit of work interface. Then when I do the implementation for the unit of work, I can do the the mapping there, and I will be able to actually utilize this. And we're going to be seeing this but in action, but I just wanted to explain why do we need it and why are we doing it this way. So inside my core folder now, I'm just going to be creating a new directory or a new folder, and I'm going to call this Repositories. Okay. So inside this repositories, I'm going to be creating a class, and this is going to refer to the generic repositories that I created previously. And the way that I'm going to be doing that is I'm going to make sure that, again, it's generic, so it's of type T. And then I'm going to inherit the I generic repository. Again, it's going to be of type T. And I'm going to make sure here that where T is class. And then it's going to say, okay, you're implementing the I generic repository, but you are missing all of those members. So let us implement those members automatically. So let me click here. It's going to tell me implement missing members. I want to implement them all. And we can see here that all of my members has been added. Now we're going to implement them all, but for now we need to do some work before we can actually implement them. So the first thing that I want to do is I want to refer to my application DB context, because at the end of the day, my application DB context is going to be what doing the communication with my database. So we're going to put protected API DB context, and I'm going to call it context. And then I'm going to put internal, DB set of type T, because here we're going to specify to which table we want to connect to. I'm going to call it DB set. And then once I have that, I can put a logger. So I'm going to put internal, let's make it protected, yeah. And it's going to be a read-only I logger of type, actually without this, we're just gonna call it underscore logger. And I want to make this without the underscore. Okay, so now that I have my contacts, which refer to my DB context, I have my DB set, which refer to the table, and the logger. So these are the foundation that every repository will need. It's gonna basically need to which DB context it's gonna be connecting to. So that's the first part. Then it's gonna know to which database it's gonna be actually executing this information, and the logger is there so we can catch anything that might go wrong, or just to have more information available. So once that is done, I need to create a constructor, and this constructor is going to inject all of these three. So again, we're going to put API DB context, so kind of equal to context. Actually, let's make this like underscore context, it's nicer. And let's make this underscore DB set, so it's nicer. And then the next one is going to be the logger. And here it's going to be, logger. Actually, it's going to be an iLogger, not logger. Okay, and all I'm going to put here is underscore context equal context, and underscore logger equal logger. And then I'm going to be referring to this dot underscore DB set equal context dot set. And here I need to set the type of table or whatever it is. So what I'm doing, okay, why is this green? Let's see. Okay, that's fine. So what I'm doing here is basically I'm initiating the DB context and the logger through dependency injection. It's going to take it all of them from the startup class. But this is really interesting. So here what I'm doing is I'm telling it that this DB set or this table, what you're going to be doing is you're going to connect to the context that we currently have. And because you have connected to the context that we currently have, what you need to do is you need to set it to type T, or to whatever T it is. And then once you set it to type T, you are able to actually utilize it. And that's the way we are currently using it. Let's see. Okay, that's fine. So once we have done all of that, the next step is we need to start actually implementing all of our actions. So again, any questions on this, please feel free to put them in the comments down below. So once we have done all of that, now let's start implementing our all. So actually, yeah, let's implement all. What we can do is we can just make sure we can say return dbset dot to list. And let's make this as an async, and let's make this to the, and let's make this awaitable. So basically all is going to connect to the DP set and get all of the list async. Now let's implement get by ID. So the first thing, I want to make this async, and then I discovered something here that this is now does not have an ID, so I'm going to pass an ID here, and I'm going to go to iGeneric repository and update the ID here as well. And then let's go back here, and here for example I need to remove this, and then I'm gonna put return await dbset.find async. I'm gonna pass the ID, and here this could be nullable, so it will be good to actually it turns null, right? Let's see, tst entity or null. So let's make this as nullable, and let's come back here and let's update this to nullable. Perfect. Now let's do the add. Again, the add is gonna be quite simple, so let's make this as async again, and all I'm gonna be doing here is put await underscore dbset dot add entity. Oh, we cannot await this, and we need to make it add async. Yeah, all I'm doing is return true. Perfect. Now for the update, I'm not gonna implement the update in a generic way. Well, I can. Let's see. So I'm gonna put await dbset async dbset dot update. I'm just gonna pass the entity, and let's see here. There's no update async, is there? Execute update async. No, just update without this. So let's remove the await, and I'm gonna return true. And as for the delete, it's gonna be similar case. I'm gonna put dbset dot delete, or dot remove actually, entity. Is there remove async? Let me double check. Nope. And I'm gonna return true. Okay. And let's make this await async. Okay, perfect. So now that I have these available for me, I have my generic DB context available, I have implemented my default repositories that I have. So what did I do here? I created my generic repository. I have inherited or implemented the interface that I needed to do, which is going to be the iGeneric interface, iGeneric repository interface. I have implemented that. And now that I have a default implementation, so what I'm going to be doing right now, I'm going to be creating a driver implementation for this. And then once I create a driver implementation of this utilizing the iGeneric repository and the generic repository, which we're going to see how we can actually do that, it will be much more easier for me to actually just after that to just refer to all of the DB actions inside my repositories rather than having everything be hard-coded into my application, or basically into inside my controller. And the reason that I do that is ease of abstraction. So what does that mean? So in case that, for example, down the road I want to switch up my DB context from utilizing Postgres to utilizing SQlite to Postgres, it's all I need to do is update my repositories. One single place, all of the data is there, instead of actually trying to implement or do the update inside the controllers, the services, so on and so forth. So here we can see the power of a repository. So now what I'm going to be doing here is let us create a new file, and this file I'm going to call the driver repository. Perfect. And this driver repository is going to inherit the generic repository. It's going to be driver, and it's also going to implement the iDriver repository. Okay. Now let's fix those references. Perfect. That's going to tell me you have not implemented. Thank you very much. as implementing the missing member. So here we can see that it has automatically injected everything that we need inside our constructor. So that's something that it took care for us directly. The next step is, what I want to do here is I just want to see how we can actually override some of those actions that has been available for us, and we're going to be seeing how we can actually create new functionalities for our database. And basically, let's say I want something other than the CRUD. So for example, let's say I want to get a driver by the driver number instead of an ID. So we're going to see how we can actually add that, implement that, as well as we can see how we can override a certain action which has been implemented already. And then we're going to be updating our controller to take advantage of this. So let's say I want to override my all function. So how can I do that? Very easy. I need to do public override async, because basically we have inheritance, so we can override. And I'm gonna put the all. Actually, we need to specify the tasks, which is enumerable driver in this case. It's gonna be the all. And for example, why is this not suitable? What did I call it? Generic. Yeah, it is all. Let's double check. Okay, let's finish this and then we'll do it. So I can do, for example, try catch if I want here. And what I can do here is I can add an extra conditions, for example, to all. So what I can do is I can put return underscore contacts dot drivers, dot drivers dot where. I can add a condition, for example, where x dot, let's say, ID is less than 100. I don't know, some condition like that. And here, for example, I'm able to utilize this, but why is not allowing me to override? So let's first put this as to list async. Let's await this. I think I know the reason. So the main reason here is I need to mark this as virtual, so I'm able to override them. Apologies for that. So virtual, and virtual is still not, it just turned 6 a.m. So apologies for that. And let's do virtual. And now if I go to my driver repository, I'm able to override it and basically add any condition that I want. And now let's see, get a driver based on the driver number. So if I want to add this new one, I don't want to add it to the generic one because I don't want every single implementation to have that function. All I wanted to do is for the driver itself. So what I do is I go to the interface for that driver. I'll add the extra functionality that I want there, and it will be automatically forced on me to implement this inside my driver repository. So let's add this here. Let's make it a task of a driver, and I want to make it nullable. And I'm gonna say get by driver number, and we're gonna pass here a driver number. And now if you take a look directly into my driver, we can see there's a squiggly line because it's telling me there's one method has not been implemented. So right now if I come here, I can see that it's forcing me to implement it, and I make it async because I have not implemented inside that generic one. I don't have to override it, I can just implement it. If I have implemented inside my generic, I need to do an override. So now what I can do is simply I just remove this, and all I'm gonna put is try. And here I'm gonna put, let's say get, so I'm gonna be returning context driver dot first or default async, and I'm just gonna be matching by driver number equal driver number, and that's it. Oh, I need to make an await here. Okay, perfect. And now let's do a build. Although it did not finish, I just make sure that everything is still working as it should be. And we can see the build has been completed. Perfect, succeeded. And now next what I need to do is I need to implement the same, so if we take a look here, I put the iUnit of work interface. So I need to implement this iUnit of work, and then all what's left is just to wire it up inside my program.cs, and then I can take full advantage of it inside my controller. So let's see how we can implement that. So inside my repositories here, or inside my data folder, for example, I can just add a new class. I'm just gonna call it unit of work. And once it has been created, the unit of work is fairly simple. All I need to do is unit of work, basically referring to my interface of unit of work. And it's good to have the disposable available, so we can actually clear up the, it's better for garbage collection. So let's put this here. Let's do the implementation. Okay, let's implement them. Perfect. So we can see here it already started implementing everything for us, which is great. So the next step here, first of all, let us assign the DB context. So it's gonna be private. Actually, let's make it public. Actually, private is better. Private API read only API DB context. I'm just gonna call it context, context, and then I'm gonna add the logger, private, read only, ilogger, without this, underscore, logger. I'm gonna add here, I'm gonna update this to have a private set. And then lastly, what I want to do is I wanna create a constructor. And inside my constructor, I want to pass these. So I'm going to put the API context, as well as the ilogger, logger. And then once all of that is done, first of all, I want to put the underscore context equal context, and then underscore logger equal logger. And then what I can do, I can just implement the drivers equal new driver repository. And then all I need to pass here is the context as well as the logger. And that's it. So what I have done here is I have wired up my API DB context and my logger to my repository, and I was able to do this connection between the interfaces that I have as well as the implementation itself. And all I have to do left here is to implement these two. So the complete async, I need to make this as an async. And let me remove this. And this is gonna be await underscore context.save changes async. Very simple. And lastly, within the dispose, I want to dispose of the DB context properly. So I'm just going to put dispose, and that's it. So here what I have done is basically I have created my implementation of the unit of work, where I have actually able to link the implement the interfaces of my implementation as well as the actual repository itself. So I created the interface, I created the implementation, I was able to link them both together inside this unit of work. So the last step here is I need to wire this up inside my program.cs, and then I can update my program, my controllers. So inside my program.cs, if I go all the way down, after this, all I'm going to be doing is just adding this implementation. So it's going to be a very simple builder.services .add scoped. It's going to be unit of work, and then we're going to put unit of work. It's very as simple as that. And now if we go back to my controller, drivers controller, instead of injecting my DB context here, I can just update this to be a unit of work, and I'm gonna call it underscore unit of work, and remove the DB context. It's gonna be unit of work, and then unit of work, and let's do the mappings here. Perfect. So now here we can see, first of all, I was able to completely remove the dependency from the hard-coded dependency of my application DB context. I'm utilizing my unit of work service in order for me to refer to my any database action that I need to do. So now all I need to do is just update my actions here. So first of all, this get method, we're gonna change this into unit of work dot drivers, and instead of all lists, it's gonna be to all. So that's it. I'm just calling now the methods. Get by ID, instead of doing direct connection like this and putting the condition here, it's gonna be unit of work dot drivers dot get by ID, and I'm gonna pass the ID. Very simple. Instead of directly adding it like this and saving changes, all I can do is I can put, all I can put here is underscore unit of work dot drivers dot add and driver. Let's make this await, and here I'm gonna put await is underscore unit of work dot complete async. That's it. Deleting a driver is going to be way more easier. So again, instead of having all of this here, unit of work dot drivers dot get by ID and ID, for example, and here instead of deleting it like this, all I need to do is await underscore unit of work dot drivers dot delete. I'm gonna pass the ID. Actually, I need to pass, well, I forgot what I did. I need to pass the driver itself. And then await underscore unit of work dot complete async. And lastly, let's update this one here. So instead of directly again calling it, I can put unit of work dot drivers dot get by ID. I'm gonna pass the driver dot ID. And updating it like this, it's gonna be equal to await underscore unit of work dot drivers dot update existing driver actually, and then all I need to do after that is await unit of work dot drivers dot complete async, and that's it. So here we can see that although the number of changes that we have done is, instead of actually referring to my API to API DB context directly, I was able to refer to the unit of work. And although it might not seem as a big change, or why do I need to do this, but trust me, whenever you want to change the database type, you want to do upgrade, you want to add any new structure to your database, you don't really need to rewire up all of those conditions inside your controller. So you can see here, like let's say I want to add certain condition when it comes to getting the driver. Instead of going to every single controller where I have get by ID and doing that, I can just update that in a single place, and wherever I'm having the get by ID function, it will be automatically implemented. And this is a very minor benefit compared to all of the other benefits that we might get with the unit of work implementation. So let's run this now. Okay, it's telling me I have an issue. Let's see, what is it? So now there's a problem with the logger, and it's correct. I have not injected it inside my program.cs. So a way we can actually fix this is by trying to removing it from here. And here, instead of referring to the iLogger, what I can do is I can refer to the iLogger factory. I'm gonna call it, iLogger factory. I'm gonna call it logger factory. And basically here what I can do, I can just create a var, it's called logger, and I can put logger factory. See if this is looking right. Yep, dot create logger, and I can just give it a name. I'm gonna call it logs. And here, instead of referring to logger, I can prefer underscore logger. And now this should work. Now let's run this again. Perfectly, it's running. Now let's try this out. So let's get all drivers now. we got an error because there's an issue while activating unit of work. Let's see what this issue is. So it says unable to activate unit of work. That's fine. Let's go back to our controllers. It should be our unit of work. See, a typo can cause that. So let's try this again. And let's go back here and let's execute this. And now I'm able to get my information exactly the way I wanted to. Let's get by ID. Let's put ID number 1, execute. I'm able to get Lewis information, perfect. Add driver, let's add George again. Execute this, we got a 200, and now if I get all by ID, I'm getting all of the information. Perfect, delete, let's delete George. Execute, 204, and now if I get all drivers, I should only be able to see Lewis, perfect. And updating, let's say I want a Petronas 1, for example, and execute. Now if I go all the way up, we can see here is still Petronas, but if I get execute again, okay, this needs to be taken a look at. Oh, okay, what is it? Okay, we got an error. Same ID is already being, okay. So this is something that we need to make sure that we are following because it's already being tracked. And what that means is whenever we are getting any number from, whenever we're doing any query within Entity Framework Core by default, it will keep track of that object in case it needs to be changed, it's got updated. So Entity Framework Core, it's very smart. So let's say we are utilizing an object, this object has been sent to the user, and basically what Entity Framework Core is basically keep tabs on that object. Does this object change? Did that object have anything that got deleted, updated, so on and so forth. But because we're utilizing an API, and basically we're having this connected mechanism with it, what we can do is we can tell Entity Framework, like, please do not track this object that we're currently getting, because we want to basically make sure that we are covering this. So let's see how we can do that. So inside my generic repository, so here, for example, what I'm gonna do is for every single one of this, I'm gonna add dot as, is it here? dbset dot as no tracking, as no tracking. And basically the as no tracking means that telling Entity Framework, do not track this object, just get me the results. And I'm gonna also do it here for the get by ID. So here we can see that we have a bit of a dilemma. We cannot implement the as for get by ID. So a way we can actually resolve this is, what we can do is we can go to the implementation of this. We can override it. So we can come here and we can just put, similar to how we override the, let's make this smaller, the all. What we can do is we can put public override async task a driver get by ID, it's taking an int as an ID. And the way we can do it, just put try again, and then here what I can do is we can put return await underscore context dot drivers, dot drivers dot first or default async. We can make that match here, x.id equal id dot as no tracking. Dot as no tracking. And now this should be able to resolve our issue. Let's try this again. Let's run this. And let's come here and let's try to update again. And basically we got a total of 4. And now if I update this, I'm able actually to get the 200 with Petronas 1. Perfect. So This is basically is how we can actually implement the unit of work within our web API. And let's do a quick overview of what we have accomplished so far. So once we have created our web API, once we are able to wire it up to our DB context, so first thing that we did is we have created our repository folders, where we have created a generic repository interface where we have specified all of the default commands that we want to implement there. So that's the first thing. Second is we have created a unit of work interface where we are actually telling we are mapping all of the different interfaces for our unit of work. So that's the second thing. Then we have implemented a default implementation within the repository for all of the default interface, generic interfaces that we have. So we created the implementation for all, get by ID, add, delete, and update. Once we have done those add, delete, and update implementation, then we have created this much more specialized implementation for the drivers. And basically from there, we were able to override certain action like the all, get by ID. We saw how we can actually add a custom command for our database, which is get driver by driver number, and we can see how easily we can get it and basically implement it. And once we have done all of that, we basically actually wrote our unit of work implementation where we were actually able to create an implementation for the interfaces. And once that has been done, we basically just wired it up into our program.cs, and then we have updated our controller in order for us to basically utilize every single aspect of this, every single aspect of the unit of work rather than calling directly the DB context. And that's it basically. And here we can see that the power of unit of work that it provides, and basically how much more flexible our API is gonna get because we are utilizing this. So I hope this video was helpful. If you like this video, please like, share, and subscribe. It will really help the channel. If you like access to the source code, please consider supporting me on Patreon or buying me a coffee. And thank you very much for watching this video, and have a great day.